Hi, welcome again to my channel. In today's video, I will give you the definition of a homologous series using an analogy. What do I mean? I will tell you a short story that makes this definition clear and simple. Okay, now, what is the story? I asked the students, how old are you? Instead of the child to give me a straightforward answer like, I am 2 years or I am 10 years old, the child started a story. And what did the child do? He said, teacher, wait, let me check. And I'm like, okay. He said, we are 5 children in our family, and I am the 4th child. I said, okay. And the child now said, the first child, my mother, is 22 years old. The second child is 20 years old. The third child is 18 years old. So, teacher, I am 16 years old. I was like, wow, what does that imply? And the child said, my mother gave birth to us 2 years apart each. I was like, oh, so now, how does this my little story concerns homologous series? Now, what is a homologous series? A homologous series is a family of organic compounds which conforms to a general molecular formula in which each successive member differs in molecular formula by a CH2 group or by 14 atomic mass unit. How does this definition relate to the child's story? Now let's see. When we talk about organic compound, in organic compound we have different families. And these different families is what we refer to a homologous series. Now, what is special about these different families? First of all, they conform to a general molecular formula. So each family of an organic compound has their own general molecular formula that they conform to. And each successive member of that family differs in molecular formula by a CH2 group. Now, if you calculate the molecular mass of CH2, you will have 14. So that's why we say CH2 group or 14 atomic mass unit. Now, what are the examples of a homologous series? We have different examples. The alkanes, alkanes, alkynes, the alkanes, the alkanes, the alkynes, the alkanols, the alkanoic acids, alkanols, the alkanoates, the alkanoates we also call them esters, etc. We have many others, the halogenal alkanes, and so on and so forth. These are different families of organic compounds. All of them represent a homologous series. So now, for instance, let me use alkanes for an example. The alkanes as a homologous series, they have their own general molecular formula, which is CnH2n plus 2. Now let me look at the members of the alkane family so that you see how it is related to the child's story. The first member of the alkane family is the methane with the formula CH4. The second member is ethane. Now, ethane, it means that ethane will differ from methane. The second member we differ from the first member by CH2 group. So the only thing I will do is just to add CH2 to CH4, and I'll get the second member. So if I add CH2 to CH4, I will have C2H6. Did you see? Each member differs from the other by the CH2 group. So the third member, which is propane, it will also differ from the second member because you differ from the successive member. So it will also differ from the second member by a CH2 group. So we add it up, it will be C3H8. And this is how the members of the alkane family will continue to progress till you get to where you want to get to. So hope now you can see how this child's story of age differences in their family relates to the homologous series, which is also a family of organic compounds. Don't forget to like, comment, subscribe. See you in my next video where I will discuss the functional groups. Bye.